Good morning. Welcome, Fluttercon. I'm really excited to stand here and talk about testing and have such a large crowd. That's really incredible. So today I want to talk to you or with you about testing, widget testing in general, and my talk is called Flipping the Testing Pyramid. But we will also talk about full app widget testing as well as robot testing, and my favorite, my own package called Spot, which helps you with widget testing. So we have a lot to cover. Let's get started. First, I want to know who is actually the audience. So how many tests are in your project? Please raise your hand if you have one test, at least one test in your project. Yes, all the hands should go up because there's one default test. Keep your hands up if you have 10 tests or more. Great, 100, 1,000. Great, but it looks good. Okay, so my goal today is show you how to write better tests because you are all already covered. So for the few people that are not writing tests, what are the reasons that people are not writing tests? The first thing is many people don't have much experience writing tests, and they feel like writing a single test is hard, writing a lot of tests is even harder, and it takes too much time. I will show you today, especially with robot tests later, that it doesn't take that much time. And I mean, these days we have LLMs, they can do a lot. But also the testing setup for applications. So if you're working on an app for more than 2 years and you haven't written a single test, it might be very hard and challenging to create the first test to make it run, even for a single screen. And yeah, I will break this down as well and give you many, many tips how to actually get started with widget tests in your existing application. We should write tests because when I write a feature, I want to make sure that it works in 2 months from now. I want to make sure that if a junior developer touches the code or an LLM, it's up to you to decide what's worse, that it doesn't break anything. And I want to be safe. I want to be safe when I commit code. I want to be safe that I can proceed, that I can stop thinking about the things that I did before because I tested it, it works. I can continue with the next thing. I can start to commit. I can even release the code. It gives me a lot of safety. And all of you have probably heard about the testing pyramid. That's by Mike Cohn. He created the testing pyramid in 2009. And when I read 2009, that's interesting because I learned it in university in 2010. So I was like, whoa, I thought this is way older. But it's not that old. He claims that we should write mostly unit tests, we should write service tests, and we should write as little as possible UI tests. I find this really odd because UI tests are fantastic. Once you have a good setup for your UI tests, they are easy to write and you can cover a lot of your code base. And it's also the way that people interact with your application. So why not do the same test as the user does? If you're asking what are actually service tests, he claims that unit tests are basically for methods, maybe classes, but everything that's bigger is a service test. And the service test may cover multiple classes, may cover entire workflows, but they do not touch UI. He's really against tests touching the UI. And yeah, again, this is odd, but we have to think about where is he coming from. And if we look at the entire developer roles out there, I looked at the Stack Overflow survey from 2024, not 25 because this question was not in there. And we see that we are actually a minority, we as mobile developer, or even we as front-end developers, because if a developer in the ecosystem thinks about front-end, they think about, yeah, front-end, browser, JavaScript. That's not true. We are the minority because we write front-end code, we are the minority because we don't write for the browsers. So yeah, we get often overlooked, and the things that work great for us are maybe not covered by general software engineering guidelines, like the testing pyramid. I actually read his book, or the parts that are relevant for testing, and he recently published a blog post where he clarifies some of his claims. And there he says, tests performed through the user interface are expensive to run, expensive to write, and brittle. And that's the reason why he thinks we should not write UI tests. But to be honest, they are not expensive to run. His claim is that the user interface takes so long that eventually the test suite is not able to run through the night or cannot be run multiple times per day. I'm not sure what kind of projects he's in, but my test suites run in less than 5 minutes, even with UI. He says that they are expensive to write, and I know where he's coming from, because if you are a team of 10 developers, most of them don't write the front end. And if you tell a backend developer to write a test for the front end to test your backend in a foreign language, yeah, this is hard. But we focus on front end. We are front end experts, so we can write code for the UI and test it with that. There's no language switch for us. So this argument doesn't count. And brittle? Yes, in the past, UI tests have been brittle. Like in 2010, yes, they have been brittle. In the browsers, they are maybe even, they are still brittle. If you think about Android and you have to spin up an emulator, yes, this fails constantly, this is flaky, this is brittle. But for us, Flutter developers, no, it's not brittle. The testing pyramid that you all learned about is actually coming from a book called Succeeding with Agile, Software Development Using Scrum. And you have to get the context. Like, this book is about Scrum, 450 pages about Scrum, and only 3 pages of this cover the testing pyramid. There are more pages, like 6 about HR, and 8 pages about offices and furniture. So, not sure if we really shouldn't pay him that much attention. So therefore, I would suggest that we rethink the testing pyramid. And yeah, let's do it like this. I call it the Flutter app testing pizza slice. We should definitely write unit tests, yes, but if we can, and it works, we can write as much widgets tests as we can. And yes, there are integration tests. I personally don't recommend them, but there are definitely cases where it is useful. But speaking of useful, when is a test actually useful? I created a list of properties that make a test very useful. The first one is your test should be very isolated, meaning it should not touch other systems. It should not call an API. It should not call an authentication service. It should work offline. Maybe touch a local database if it's mocked, but better, it should run in memory entirely. It should be very reliable, so the order should not matter. If you run your test in any order, they should work. They should not have any race conditions. They should not depend on each other. And they should be fast. My general rule is, if I have a test suite that runs in a few minutes, that's fine. 5 minutes may become annoying. 10 minutes is usually too much. Then you start merging before the CI is ready. So I recommend try to lower it under 10 minutes. If you go over, try to optimize it. We recently had a project where we went from 12 minutes back to 6 by just doing a few optimizations. Pump a few times less, shorter, things like that, like optimize our tests. They should be deterministic, of course. Only when something in your repository changes, the test can fail. There should be no other reasons your test can fail. And they should be easy to debug. That's something that I see in many other languages and frameworks. Like debugging is sometimes very hard. And I personally think that debugging is very helpful, especially if you run into errors. I also don't like mocks. I recommend that you write fakes, because fakes have states. And while debugging, you can see the actual states at every line of your test and see what's going on. Useful error messages are very helpful. Always try to make your test fail at some point and see if you would understand why it's failing. But even if you write great tests, there's a time where your test dies. Maybe your test dies together with your project because it's discontinued. You started working on it 15 years ago, and now it's time to start a new one. But the test has maybe other reasons to die. Let's talk about the life cycle of a test. First of all, the test is created. That's wonderful. That's very useful. We now have a test. You get celebrated by your team, maybe by your product manager. If you write a cool end-to-end test about the payment process, you probably get a lot of applause that this is finally covered and you can see if something breaks. Then your test should be definitely executed continuously. With every commit, with every change, your test should run. If that's the case, that's even more useful than just having the test. If the test is not executed, it doesn't help. And at the peak of the life cycle, the test actually prevents a regression. That would be perfect. That's the reason why we do this. At some point, a test might become annoying. You have to refactor a bit more code because you also have the tests that have part of your API. But after that, there's dev. And there are many reasons for the dev of the test. It might be deleted. And this can be a good thing. It might become obsolete. The feature is not needed. Therefore, the test is not required. It could be an accidental deletion. I've seen that happen a few times. They could be skipped at some point. And I read a research paper. If a test is skipped at one point, there's a 95% chance that it's never be included in the test again. So don't skip, fix it. A test might be commented out. You might do a big refactor, comment out a test, and forget it. Or it might be entirely forgotten. I've seen teams migrating from one vendor to another, giving over the repository, but there might be an end-to-end repository with many, many tests, and it's not handed over, or someone forget to give the credentials for the production environment. I personally claim that end-to-end tests die earlier than unit tests. The closer your tests are actually to your code, and they are not in a different repository, they are not managed by different teams, the closer they are to the production code that's executed, the more likely is that it lives forever or as long as the project does. A bit more about end-to-end tests and why I don't think they are very useful. Emulators can be flaky, we talked about that. Other systems can change. This happens all the time. So one day, even without a change in your repository, the test might fail. And you have to think about, if a test fails, who's responsible? If the test is just part of your repository, it's your responsibility. But if it touches other systems, now 3, 4, 5 different departments might be involved, nobody has time to look into it and to fix it. So yeah. Credentials might get lost. It's just too much work to migrate it. Maybe you're migrating from GitLab to GitHub or vice versa, and the setup is different and maybe too hard to get started. And maybe the tests are too slow. Nobody is looking into it. If your test takes an hour, you might not wait for the result before you start merging. In the end, end-to-end tests die earlier. That's why I don't recommend them, but they are not bad in general. Let's talk about full app widget testing. So we start with widget testing, and then I will migrate to full app widget testing. A widget test is something like this. You start pumping a widget. I think most of us have seen this. I personally claim that your app is also a widget, so why not pump your entire application? It's obviously not that easy. If you try this, you will probably run into an error. Therefore, I recommend you to think about your application like in the hexagonal architecture. You have your entire code base in the middle. That's your application code. And you have port at the edges, at the boundaries. Ports could be adapters for databases, shared preferences, I don't know, networking APIs, something like that, or plugins. And once you identified these ports and maybe wrap them with interfaces, something that you can mock in your tests, you can use it and do dependency injection. So instead of like pumping our widget awesome app, we pump our widget awesome app with a database and an API. In our production environment, of course, those are the real APIs, the real databases. In this case, it's just an in-memory database and a fake API. And suddenly, you can pump your entire app, and you will probably end up on the login screen or something like that. So I want to show you an example. This is a test that we will go through more or less line by line, so that you get an idea what's happening and how we improve it in the long run. So this is an example application that you can actually see at the Lean Code booth. This is from the Petrol package. And I think the example is quite good because it shows a lot of things that you can do with widget testing. And let's start at the top. We have a main function, then we start a test with test widgets. Nothing special here. We give our view a size and a pixel ratio. And then we pump our application. I don't need dependency injection here. It doesn't have any ports. The first thing I do is I have to tap a button called the Go to Quiz button. We do that, and we have to call pump and settle. Pump and settle because we need to pump frames. We need the next frame, and because the animation of the button, the tap animation, takes a few milliseconds, we pump as long as there's work to do on the UI thread or there are scheduled frames. Once we hit that, we go to the start screen, and we also tap the start button. As easy as that. We get to the widget selector quiz, and first of all, we have to enter our name. There's the tester enter text method where we can just enter a name into a text field. There's only one text field on the screen that makes it very simple. And then we have to select like 3 colors, the colors for petrol. We do this with a for loop, iterate over those colors, and just tap the boxes. And at the end, we tap the ready button. I think so far everything is clear. Now there are some challenges that we need to solve. The first one is we have to tap the elevated button at the bottom. There are 3 buttons, but only 2 of them are elevated. And we have to find the one with the center text. You have to see the widget implementation, and then you see which one is actually centered. It's when you set the caption. Okay, we found that. Then we solve the next question. It's a bit more challenging. This time we use a lot of the Finder API with find.ancestor and find.descendant to basically do a great query about these list tiles with the button and the dash inside. So here we have to check the A and click the button of that. And the final challenge is a list view. There are many items in the list view, and we have to check or click the third item in the list view. Scroll a bit down. There's a method called drag until visible, and we scroll until we hit the third one. And yeah, this test runs quite fast. There are like 8 taps, 2 drags, and it runs in a second. Usually the first test, the first widget test, takes a bit longer. So if you would repeat the same test over and over, I think there's like an initial delay or initial penalty of like half a second. So it's quite fast, and it covers a lot of stuff. Try to replicate the same thing with a unit test. You would have to write a lot of code to cover the logic. If you write your widget test, or if you write your full app widget test, you have to mock a lot of things, especially when it comes to plugins. I recommend like a setup mock method where you, first of all, mock, for example, the shared preferences, and in the next step, add a tier down so that after the test, the shared preferences are actually reset, and we don't have any leftovers for the next test. Tests in the same file run in the same isolate. This means there is shared memory, and you have to reset everything. And unfortunately, plugins tend to have singletons. Therefore, we manually have to reset the values in those singletons. If you are writing widget tests, you should really feel like the end user. So instead of like exposing some hidden API with visible for testing or something like that, to know if something has finished or a network request has finished, eventually failed or something like that, you should really think like the user. The user has no way of knowing what the internal state of your application is unless you show it on the screen. Therefore, it's always great to write functions, helper functions like this, wait for loading indicator to vanish, for example, which just waits for the loading indicator until it disappears, and then I can continue with my screen. That's exactly how users operate. They click a button, they wait for the loading indicator to disappear, and then they complain that nothing is shown. If you migrate your entire application to be fully testable, like you can pump your entire app, you may encounter things like the date time. The datetime constructor, the default constructor, uses your system time, and we don't want the system time because in Flutter we have an internal clock that we can manually move forward, and we also want to use this clock that can be faked in our production code. So go through your application and replace the datetime.now constructor with the clock.now constructor, and everything works. And once you successfully start pumping your application, maybe you click a button and you successfully finish your last line of your application with an assertion, the test might still fail. And the reason for that is that you forgot to dispose some timers. Usually there are many, many timers in your application, some UI delays, something else, maybe an animation, something like that. They have to be disposed. After a widget test, the Flutter test framework will pump basically an empty container, and then it will see that all the timers that have been created during that test should be disposed. If they are still running, because the widget was removed, your app was removed from the widget tree, therefore it should not leak any timers, and if it's still running, it reports an error. So you have to be careful. If you use future.delayed somewhere, you probably run into problems. You always have to use a timer, and then because a timer allows you to cancel it if your widget gets popped from the screen. And again, don't use singletons. They are very bad for widget tests because, yeah, of shared memory. Use single instances. It's totally different. A singleton has shared memory. You cannot delete the instance, whereas a single instance, you can create a single instance for each test, and they have no shared memory. You have to use dependency injection. You can inject it with the constructor. You can inject it with, I don't know, Riverpod or provider. I really don't care, but that's something that you have to do. Okay, so far, if we looked at our test, it was a lot of code. And I'm honest, I would never write this code. This code, let's go back to my cone, this code is brittle. If something changes in the UI, it will probably break many, many tests. So instead, I recommend you to write testing robots. Let's compare it. This is the large test that we looked at, and on the other side, you can see the short one, which is way, way better to read. It fits on the screen, and it's the same thing. It's the entire test. Let's look into it, what it actually says. So it's the same test, but first of all, we start by creating a robot, and the robot has one method called launchApp. And inside this launchApp method, we have everything that's required to actually get our app started. We have all the mocks set up. We eventually created a fake user and are already signed in so that we are ready to get started and get started with our test. And then we do just user interactions. We enter the quiz, we start the quiz by tapping the buttons, we enter the name, we select the colors, we submit the data. And then we solve the 3 puzzles. Super easy to read. Let's look how it's actually implemented. First of all, the quiz robot. The quiz robot takes the tester, that's our reference to the screen and allows us to do the interactions. And the launchApp method has the same code as we did before. It's just moving the code into a different class so that it's easier to handle. It sets up the view, it loads the app fonts, and then it just pumps our application. This is the point where you can do the dependency injection depending on what you need for your testing. The other methods are super straightforward. Sometimes even just a line of code, tapping a button, pumping automatically. I really like tests where there's not a single line of pump or pump and settle. Move those to the robot because this is just clutter inside of your code. Selecting the colors, also quite easy, give it a list. And you can also make these robots super smart. So for example, think about, there could be a method called go to settings. What stops you from implementing go to settings for all of your screens in your application? Because as a user, no matter in which screen you are, you probably know how to go into the settings screen. And it might depend on where you are in your application. You maybe have to pop a few screens, or think about tablet versus phone. Your robot can be super clever and work for both. And maybe there's a different button to go to the settings on a tablet versus a phone, or a different route through your application. But you can basically query what kind of screen size you have for what's currently on the screen, and then depending on that, navigate your screen. And once you have those clever methods, writing a new test, that's super easy. Think about this. You could just copy-paste this and at some point click something else. Write a different name and see an error message and assert that. So yeah, make your robot smart and very useful. I want to give you some more examples of what is actually possible with widget tests. And for me, that was quite new. Yes, you can run your widget tests on different screen sizes. That's super helpful, not only because on an iPhone SE, it is probably harder to tap buttons. You have to scroll a bit more. But you can also run it on an iPad or anything else. And you can also change the orientation, especially if you're working on tablet applications. Switching from landscape to portrait is fantastic because sometimes you lose views. And if you flip back, you expect that the views that were there before should be visible again. I've seen so many bugs, and Flutter is one of the only frameworks that allows you really to do that. So we should use it. It's super helpful. Otherwise, a human or your end users have to test this and find the bugs. You can test that your application goes to the background. You have full access to things like the lifecycle of your application. So you can just move it to the paused mode, like if you switch to a different application. Not killing the app, just move to a different application. And then another method, move your app back to the foreground. Yeah, that easy. Widget testing is great, but 2 years ago, I wished it was better. That's why I created Spot. Everything you've seen so far was just written with the Finder API or the tester, and I found it at some points a bit lacking. So let's look into the Spot package and what it actually makes better about widget testing. First of all, matchers. The find API is a bit limited. You've seen the ancestor and descendant part. It's not easy to read. I created a way that you can actually chain those selectors, so you can find a submit button in the home screen with a quite simple syntax. My chainable widget selectors are also faster. Because I know I only have to search the home screen for the submit button. I narrow down the search space and make it way faster, whereas the find API uses a different approach and always queries all widgets on the screen, no matter how far or how deep they are. I created a timeline. I will show you a demo in a second. So basically, when you run your test or your test fails, it will generate you an HTML report with all the screenshots of your application. Super useful. Your test fails, and you can actually see what's on the screen and why it fails. And we worked a lot about doing better error messages, but I will show you some examples. Let's look into a simple app. Here are the comments, which show the Finder API. Instead of the test.tab, we use act.tab. Instead of find.byType elevated button, we use a spot with the type elevated button, and it will search the screen for that widget. We can chain the widget selectors with a spot scaffold, spot text mont for the French people here. And at the end, if something goes wrong, it automatically generates a timeline report. Once you add a single assertion with Spot or a single API with Spot to your test, it will automatically generate the timeline for you. Here's another example of what the chaining looks like and how it's different. So the chain at the top, I think quite easy to read. We go to the login screen, we search for the login form, and there we take a text field or all the text fields. Whereas at the bottom, I'm quite used to that, but I still find it hard to read at the bottom. And if I find it hard to read, your coworker does probably as well. So what happens if a test fails? Think about the last time you wrote a widget test and it failed on the CI. You probably see an error message like this: found 0 widgets with text, weiter in this case. Yeah, the text was not found, but it doesn't tell me what's actually on the screen. Why is it not found? Am I actually on the correct screen? Has the text changed? I don't know. I was pretty frustrated with that, so that's why I created Spot. And a Spot error looks a bit different, because I search here in this case first for the form page, making sure I'm on the correct page. Then I search for a PT elevated button, making sure I get the button. And then I add with child spot text and search for a child with this text. This means, because I gave a bit of context how to search for the widget that I want, if it fails, it can tell me, yeah, I did find the button, or I did find at least one button, but it has a different text. That's way, way more useful than just saying the text is not there. Additionally, I told you this before, we have a timeline. So if you now scroll at the very bottom of your output of the test, you can see view timeline here. And there's a smart link that opens an HTML page, which was generated after the test. It is completely local. And if you open the output, it looks like this. And suddenly, there's a screenshot of what actually failed here. And we can click the screenshot and get an annotation. Oh, yes, we found this button. This button is there, but the text is ready. Oh, yes, of course, I probably did a localization error. Easy as that. You can see very, very quickly what's actually happening. The HTML page is also written in Jasper, which is a very, very cool web framework allowing you to write HTML pages in a Flutter style. So just want to promote it here. Working pretty hard with the community here to get everyone on board. And with Kilian, he did the actual initial implementation. I'm very happy that it's now not string concatenation for the HTML, but actually something useful. Additionally to the screenshot, we also print the widget tree. And by searching the text, you can probably also find what's actually going on, what's actually on the screen. Because we have the context, we know you are searching for a button, we can only print the widget tree of the buttons on the screen. So it's not the entire widget tree, but only the part that is actually relevant here. Once you add more and more features and convert the finders with the matchers of Spot, you see more and more elements in your timeline. So every time you make an assertion in your application, we will create a screenshot. Not right away, only when the test fails. We will create a screenshot afterwards and render it to HTML. All of this data is locally. So in your build folder, we will create a new folder with all the screenshots, with the events as JSON, all the events that were happening in your application and that you added to the timeline of Spot, and the HTML itself. And because all of this is local, LLMs are pretty happy about it. So you can tell, oh, yes, we are using Spot in this package. If the test fails, check the output. There's a link to the HTML. You know how to look for the screenshots. You know how to read the maybe the events JSON, how to read the index HTML. And the LLM can also, most of them, can also interpret the screenshots and see what's actually happening. And that's way, way better than I did not find the text. I don't know what's going on. So yeah, if you write a lot of widget tests, please check out the Spot package. It makes your tests way, way better. And I want to show you a few more aspects of the Spot package, why you should actually use them. First of all, screenshots. We take automatic screenshots, and we learned that screenshots are great, but screenshots with text are even better, because otherwise they are just boxes and you have no idea what's on the screen. By default, you see those boxes as text. There's a font that renders just boxes by default, but you can load the fonts of your application automatically. And if you call the load app fonts method, you will see automatically the fonts in your screenshots. There are other packages that also load app fonts, but they usually just load the Roboto font. If you have other fonts in your application that you use, you want to use our Spot implementation because we actually go the hard way. We parse the font manifest and we load all the fonts that are available. We also have a better implementation of tapping widgets on the screen. Most of your UI tests will tap somewhere. Some will scroll, yes, but tapping is really crucial. And you will not only see, in a normal widget test, you have no idea where the tap actually happens. With Spot, you will see a crosshair and see exactly which pixel was tapped. That might be useful because your widget might be covered by something. We have also a lot of other checks. So for example, we check that the button that you are clicking is actually in the view bounds of your screen. A user cannot click outside of their phone, but we can, because it's still part of the widget tree, we can theoretically send tap events to buttons that are not visible on the screen. If buttons are only partially visible, maybe there's a dialog on top, it's still part of the widget tree, but we detect that the click does not go through, and we tell you which other widget is covering or is receiving the click event. And yeah, we pump automatically, so you don't have to call pump, like the single pump for a single frame after a tap. We do this automatically. It saves a ton of code once we introduce this change. And if multiple widgets are found, we are not telling you, yeah, we could not tap that button because there are 5 of them. We tell you, oh yes, we have 5 of them. Which of them do you actually want to tap? Here's the context where they are located. You can see on the screenshots all the buttons that are highlighted because we found them. You can also make manual screenshots. That's where we initially started. We had a method called take screenshots. And it can be very useful if you do actual pixel testing. For example, we had a button with a border, and checking the actual border, depending on the implementation, it might be very different. The widget tree might be very different. But you can get the outline of the border and go 1 pixel in, and that's probably the outline of the button, and get the color of it by just getting the pixels. So sometimes it's useful to take screenshots of the entire screen or of single elements on your screen and do the assertions with colors like that. Today is my birthday. And you can do me one favor. Please like the package Spot. That would help me a lot. And you can also try Spot in your next widget test. Thank you.